First things first, we're going to go over this graph problem. I'll go ahead and tell you now, this is on the test. So if you're looking at this like, nope, then you're noping it on the test too, because it's going to be there. That's why we're doing it on the notes. We're going to practice. The easiest way to approach this problem is to highlight each of these 3 graph types with a different color. That's my recommendation. It is doable with the same utensil, whether that be a pen or pencil. I'll show you what I did the first time I did this problem. This is all in pen. I circled the linear function. I did a squiggle along the quadratic, and then I bolded the exponential. It still doesn't look great though. Really using different colors, it looks the best. So that's how I'm going to do it here. So take a moment, do that however you please. I'm going to highlight each line in a different color. Will you turn that down, please? I can hear that.
I can't turn it down.
Thank you. Thank you. I'm going to go ahead and label all 3 of these with their names. If you're still highlighting and whatnot, finish in the next 30 seconds, please. I'm going to move on. I'm going to preface this by saying these problems are not difficult. You just have to make sure you're answering the question that's being asked and you're looking at the correct part of the graph. When we do these problems, we're focusing on specific parts of the graph at a time, not the entire thing as a whole. Number 5, which function has the largest x-intercept? Of course, you have to know what an x-intercept is to answer this correctly. When it says x-intercept, where am I looking on the graph? Yeah, the bottom at the x-axis. The x-intercept is where it crosses the x-axis. So when it says largest x-intercept, we want to know the largest number on the x-axis that's being hit by one of these graphs. So let's go to the bottom of the graph here. We can see that the exponential function's hanging out around 0. At 1, the quadratic is hitting the x-axis. At 6, the linear function's hitting the x-axis. And then the other side of the quadratic hits at 7. This is the largest x-axis value. The largest x-intercept quadratic is the answer. You just have to put the name of the function. You don't have to get more specific than that. Number 6 asks the same question, but for the y-intercept. So this time we're going to look at the y-axis to answer. Same thing, let's glance at the y-axis and see which one is the largest. Again, the exponential function's still hanging out down here around 0. Go up, the linear crosses at 6. We're missing a function. When you can only see 2 of the 3 functions, you need to see where the third one's going because it's off the graph, and that can absolutely affect your answer. So we're missing the quadratic function, and if we follow it to the left, it's clearly going down, so it's going to cross lower than we can see on the graph. Clearly it's not the highest, so we could ignore it at this point and just focus on linear being the highest. Number 7, list the functions in order from smallest to biggest. I'm going to come back to that terminology in just a sec. When x equals 4. When it says smallest to biggest, from a visual standpoint, what you're looking for is lowest to highest. That's the easiest way to view this problem and get directly to the answer. At x equals 4. So let's go to 4 on the x-axis. It's right here. And I'm going to draw a vertical line through it. So follow that grid line. What I'm going to do is take note of every time it hits another function along that line. So the first time we hit is here at the linear function. Traveling up, we very quickly run into the exponential function. And going all the way towards the top, we finally hit the quadratic function. All 3 of these graphs are functions, so they will hit the vertical line one time. Once you've found all 3 places, then you're good. You've got all 3 accounted for, and you just go in order from lowest to highest. So the first function I hit was linear. Second function I hit was exponential. And the third function at the top is quadratic. Smallest to biggest means lowest to highest. Number 8 asks us to do that again, but for x equals 6. So let's repeat that at 6. Again, let's take note of every place that this vertical line hits another function, another graph. We're starting low down here at 6 on the x-axis. We hit the linear function. Traveling up, we hit the quadratic function. And the exponential function is nowhere to be found. We must look for it. It's off the graph. It has to be included in this. Now, I'm sure you all know this is not just going to fall off and disappear. It's going to keep going. We just can't see exactly what that looks like, but we have a good guess. This graph is slightly curved to the right, so it's going to keep going this way, ever so slightly. So I'm going to exaggerate this change, but just so I can get a visual, it's going to end up doing this. So now I can see that this is going to cross somewhere way up here. That's clearly the highest function by far. So that's going to be the last one in my list. I'm going to write those down in the order that I hit them, from lowest to highest. First, I hit the linear graph. Then I hit the quadratic. And then up at the top there, I hit the exponential. Questions on 7 or 8 before we do 9? Number 9 is a very similar problem, except we look at a range of numbers. We don't just look at a single one on the graph. Which function is smallest? So smallest refers to lowest. Smallest to biggest, lowest to highest. Smallest. Between. Now that word between there kind of gives away what this notation is getting at. So with that word between, this will be really easy for you to interpret. This means that x is somewhere between the numbers 2 and 3. Notice that it's not equal to, not a major deal here. But between 2 and 3, what's going on there? Which function is smallest? So here's how I look at it. I'm going to identify both of these numbers. Here is 2 and here is 3. So we're doing that range of graph, that section of graph. I'm going to draw both of those vertical lines. If you can't tell, I've been using black marker. I'm going to shade between these two lines in pencil because I'm not trying to cover up the graph pieces, but I'm just trying to emphasize this section of graph. This is what I'm looking at here. So shade it in enough so you can tell that's what we're focusing on, but not enough to cover up the actual lines. The question is, in this shaded region, which function is lowest among the three? Hopefully the shading, the coloring makes this very obvious to answer. Which of the three is lowest? Got a 33.33% chance of getting this right. Which function is it? Yeah? Which one? I'm sorry, one more time?
2.5.
Where'd you get 2.5? Oh, no. Which of the three functions is lowest? Yes. Exponential is correct. Were you trying to locate the actual value of it? Yeah, no. That's too much. That's too much. Just give me a name. Exponential is the lowest of the three. So as you can see, that question very much depends on which part of the graph you're looking at. You can get a different answer depending on where you're looking. So that's why it's important to block it off, focus on that one region. Number 10. Which function has a negative rate of change? Reminder, you're taking the SAT in a week and 2 days, and they love this phrase, rate of change. It's just a very fancy way of saying slope, for those who don't know. Which function has a negative rate of change slope for the entire graph? That's correct. Thank you. An entire graph is key here. Now, I've already been given the correct answer. It is linear. Entire graph, though, is important criteria because the quadratic goes down for half of the graph, but not the whole thing. Linear is the only one that's constantly going down, so that makes the difference. So if you want to write an explanation, if you're still not clicking with that answer, you can write this down. If you've got it, just don't write this down. Another way of putting these directions goes down the whole time. We know it's going down because it's negative. Questions on graphs before I move to word problems. All right, let's get this part over with. You all have this table at the top of your paper. We're not going to use it. We're going to write something else that's completely unrelated to this. So you can X out of these boxes and then this here. I need this space though to write important information. So ignore those titles, ignore everything. Just focus on what I'm going to write here. To solve these word problems, they are all exponential word problems. You need this information. Y equals A times 1 plus R to the T power. Let me give you some definitions. A is the starting value. That's what we begin with in the problem. Starting price, starting amount, those kinds of things. R is rate, and you'll be able to tell what it is in the problem because it's a percent. Lastly, T just stands for time. And this is a very general term. It can represent days, months, weeks, years, hours, minutes. It just depends on the problem. You have to know this criteria so you know what you're looking for in the problem. Number 11, it's going to ask you if it's exponential or linear. I'm telling you it's exponential, so ignore that part of the directions. There's also a slight typo. I'll let you know when we get there. The price of a computer component is increasing at a rate of 15% per year. That directly says rate. This is our R value. State whether this increase, not decrease. Increase is linear or exponential. I've already told you it's exponential. If the component costs $180 today, that part's important. Write and use the model to determine what the cost will be in 5 years. They're giving me a time to look at, so this is my T value. Meaning that other information I boxed, the 180, that's my A value. So they're saying today it's 180, what will it be 5 years from now? That's how I know it's a starting value, A. So they want me to find the new value. First, let's just fill in the equation. Our equation, again, is y equals a times 1 plus r to the t power. I'm going to make my variable list, a, r, and t. This time I'm filling in those numbers, not what those three things mean. A is 180. We'll drop the $sign for now. R is our rate of 15%. It's an increase, so I'll put a plus in front of that. Plus 15%. Here's the thing, we can't put percentages into formulas, equations. They're in the wrong format. Anytime we plug in percents, we have to put them in their decimal form. We reviewed how to do this, but backwards. Now remember, percents are bigger than decimals. That's kind of how I remember this. So we need to make this number smaller. So we're going to put the decimal point at the end of that number. As it is a whole number, that's where it would go. And we're not going to move to the right because then it would get bigger. We're going to move to the left to get smaller. So we're going to go back 2 places. So our new rate as a decimal is plus 0.15, no percentage. This is how we must put it into the equation. T as in time is 5. They give us that, it's 5 years. We have all of the components. Let's put them in the equation and solve. We have y equals a is 180 times 1. Our r is plus 0.15. And our t is 5. So this is to the 5th power. I'm going to go one step before the calculator, not because it's hard to type into the calculator like this, but there's a point I want to make here. So let me add these two numbers in the parentheses. This is y equals 180 times 1.15 to the 5th power. This number in parentheses is bigger than 1. That means this is an increase, which we already knew based on the problem. But in a moment, we're going to do problems where we're given the equation and we have to determine increase or decrease. That's valuable information to know. All right, we can type this into our calculator to get our answer. And we're going to have to round. This is a big one. As long as you type in exactly what is written, you will get to the correct answer. We have 180 in parentheses 1.15. Don't forget the caret for the 5. This is an exponent, not multiplication. There are no rounding directions, but we could actually make a good guess on what this should look like. This final number is a money amount. How many decimals are we allowed to go out to in money? 2 for the cents. So we're going to go out 2 decimals. The third decimal is a 4. It's not 5 or larger, so we will not round up. This is going to stay as it is. $362.04. That will be the new price 5 years from now. Questions on this first problem? We are making great time here. Number 12 is a very similar concept. Due to extreme drought, the depth of water in a pond is decreasing exponentially by 2%. They give a percent. This is our R value. Decreasing exponentially by 2% per day. If the depth was initially 30 feet, initially, the word initial means at first, the beginning. So this is our beginning value, A. Initially 30 feet at the middle of the pond. I'm going to pause here. Forgive me, but this is actually 2 problems in one, and you only know this purely from experience. So as newbies to these kinds of problems, you wouldn't read through it and notice what I noticed. So it would have helped if we had spaced these out or made that clearer, but I'm going to point out where this is. Write an exponential equation to model this after t days. So that first part, they tell you just let t be t, don't plug anything into it. This is technically part 1 of this problem. And then this last sentence is part 2. Find the depth after 8 days. This is part 2, and they tell us that t is 8. Basically, they want you to write just the equation with t not filled in, just let t be t, and then they want you to find, in a second part, find it specifically once you have a value of t. So like I said, this one's a 2-parter. First part, we're going to make the equation. Our form is y equals a times 1 plus r to the t value. And we're going to fill in our 3 variables. A, R, and T. Now I've just gone on and on about how T is T, so I'm going to go ahead and put that now. We're not actually putting anything in T's place, it's just going to stay as is for now. A, 30, already labeled that. R was at the very beginning. It says decreasing, we must put that minus in front of the number. Just like how in increasing I put a plus in front, decreasing you must include a minus. Minus 2%. Again, we need to convert that to a decimal. So we'll introduce a decimal point at the end of the 2. And we go 2 places to the left to make it a smaller number. This is minus 0 point, that gap I have here, that is going to get a 0, 2. No percentage. Now we can plug everything in and make an equation. Y equals, my A value is 30, times 1, my R is minus 0.02, and T is going to be unchanged, so it's just going to be T for now. When they ask for the general equation, that's what this is, you do need to simplify it, so I am going to take another step and rewrite this inside the parentheses. Y equals 30 times 1 minus 0.02 is 0.98 to the T value. Before I do part 2, I just want to make a point here. In the previous problem, that number in parentheses was above 1. That means there's an increase. In this problem, this number is below 1. The percentage is less than 1, so this is going to lead to a decrease. Again, we already knew that because the problem told us that this is what we look for when we're trying to determine increase and decrease. Let's do part 2 of this problem real quick. Part 2, we have our equation already. We just need to plug in 8 for T. That's all we got to do. We have Y equals 30 times 0.98 to the 8th power. And then we'll let our calculator do that part for us. This will be another rounding problem. I'll round the same way as I did last time just to be consistent. (30 times 0.98 to the 8th power, rounding to 2 places. 52, and then we're followed by a 2. The 2 is not large enough to bump this up, so we will not round it up. It's just 25.52, and this is feet. Questions on number 12 before I do 13 and 14? 13 and 14 are very quick problems. Given the following exponential equation, identify whether the change represents growth or decay, and determine the percentage rate of increase or decrease. So this one has 2 answers to it. First off, let's talk about growth and decay. Their names kind of imply what they mean. Growth means you're going to have an increase. Decay, it's dying, it's going down, it's a decrease. So we need to identify 2 things here. Whether the change is growth or decay. And we need to determine the percentage rate of increase or decrease. So we need to actually find that number of increase or decrease. Looking at our equation here, I've said before, it's a number in parentheses that tells us this information. So that 0.97, that is all we care about. I could go ahead and write this down now. That number is less than 1, so this is a decrease. But how we find the number is a very easy method. You take this number minus 1. So I'll do that. We have 0.97 minus 1. That is negative 0.03. Now remember, they want the percentage rate of increase or decrease. So we're going to need to put this back into a percent. Percents are bigger. We're going to move to the right. Move 2 places to the right. This is negative 3% decrease. So that means we have a decay problem. Number 14 has the exact same instructions. We're going to do that again. We take the number in parentheses and we subtract 1 from it. 1.603 minus 1 is 0.603. Again, we need a percent here, and notice that this number is positive this time. We're going to go 2 places to the right to turn it back into a percentage. This is 60.3% increase, which means we have growth. Just a quick clarification because it's just now kind of hitting me. Go back to 13 real quick. Technically, if I put negative and decrease, that's a double negative. They cancel each other out. So technically, this should just say 3% decrease. But the negative tells you it's a decrease. So don't put both of them together. 3% decrease tells you it's negative. I do want to make that quick change there.